Good afternoon, everyone. My name is Kathy Galindo,
My name's Cole Cornell.
I'm Anthony Woods.
And I'm James Prendergast.
and this is our Invent for the Planet 2026 Ashes to Glasses.
So starting off with the needs statement, we decided to challenge ourselves with is the second one, and this is just pretty much how would we change and restructure food systems and significantly reduce the food waste and improving efficiency, accessibility, and sustainability.
And with that problem being stated, our problem that we decided to take from this need statement is how can we repurpose food waste into glass in a way that reduces or eliminates shortage of material, with the sub-problem being how can we reduce the production of glass's effects on the shortage of sand. With that being said, our solution is this: corn husks, rice husks, and eggshells that are processed to extract silica and produce a biosilica glass, thus replacing the sand in glass manufacturing. This will result in materials that can be used in architectural glazing systems.
So our 5 design requirements are 1, sustainability, 2, efficiency, 3, versatility, 4, cost efficient, and 5, ornamentation. So with 1, we use sustainability, such as what Kathy said before, the corn husks, rice husks, and eggshells that help reduce the waste and kind of reduce the agricultural burns, which we'll go more into later. Number 2, efficiency. The rice husks contain a high level of silica, allowing for us to replace that mined sand that we have today. And some statistics are 6.5 million yearly rice production in the USA, and 46% of that is wasted due to farming and processing. 432 million yearly corn production, and 4.7 of that is also wasted in farming and processing, and then 190 billion is lost over the past 5 years in agricultural field burning. Number 3, you have versatility, where you can make agri waste can be made into molded or cast textures, allowing for different architectural styles and facade systems. 4, it's cost efficient, so lowers cost for like the farmers and food producers. And number 5, ornamentation. You can make it into different colors, patterns, and textures, as I said before, helping that decorative surfaces and architectural systems.
Going into this cycle, it all starts off again with the food waste, and then it is burned, becomes agricultural husk ash. And then going into that, the silica is extracted and then melted into architectural glass, which goes off into 2 things: construction applications, and then geodesic domes, which is like a 3 we'll talk about later, and inevitably to grow food, and it's a whole cycle.
So we have a lot of issues with food waste today, obviously. 1.3 billion tons of food is wasted annually. 13% of the food production is wasted after harvesting. And a lot of people ask where that happens. It happens in households, food services, and retail systems. Generates 8 to 10% of general greenhouse gases emissions. And then the global economy wastes about 1 trillion USD dollars yearly on food waste.
Now, issues with glass today is mainly the components that are used to create this, and that is sand. So there are 50 billion tons of sand that is used in within like materials that to create both architectural glass, concrete, asphalt, and electronics. And our goal with creating a solution to this problem is to limit that sand use, because this natural resource is so widely used. Now getting into the prices of glass. So the price of glass has cumulatively grown over the years, and this is due to the rising energy cost, the raw material shortages, and then the environmental regulations. So with our solution, again, we are trying to attack this raw material shortages in hopes of lowering these prices and helping just make these this glass less expensive due to like some research that we've done. Like average window today, it costs from $300 to $650 to replace.
The types of sand used in construction are mostly river, natural, and pit fill sand. And in 2022, in the United States, concrete aggregates in construction total valued over $1.4 billion. And in that same year, California consumed 100 million metric tons of construction aggregate and sand too.
Right, so getting into agricultural burning. So this like covering, I guess, what we was talking about earlier is just the idea of intentional burning or farming practice that is for crop management, pest and disease control, and then cost efficiency. So 20% of crops worldwide has been burned, and then we're going to get into like the harmful and impacts that was caused from this.
So the impacts from that, you have impacts on the soil. So you have the loss of soil biodiversity, where you loss of fungi and more like smaller animals. And then you have the atmosphere, which affects climate change, as we all know today. And then you have smoke and haze, which affects your visibility and your air quality. Then we have health risks, like long-term effects like cardiovascular and eye and skin irritation and diseases. And then you have economic, you have productivity loss with disruptions in traffic and other material stability around.
So how we're gonna produce this glass model is with the sol gel process. Now, the sol gel process is the chemical method to produce solid materials into molecules. In this case, we're gonna do our ash to gel-based silica. So we're gonna start with our silica source, which is our eggshells, our rice husk, and our corn husk. We're gonna ground them up, and then we're gonna put them into our liquid ingredients to create our sol solution. With that sol solution, it'll then get processed in with some pH. The higher the pH, the better it is for the strength of our glass, and it's easier to mass produce. Once that is all put together, it is formed into a wet gel substance, which then will get into their gelling process. The gelling process is a state of hydrolysis. And in the state of hydrolysis, you could either use water or ethanol. And depending on which one, it will determine how long it takes for the gel to form. And then once that gel is produced, it sends into the drying and curing process. And the drying and curing process is a very delicate system, which is either express heated or a very delicate quick. And then we're going to talk into bioactive, decorative, and soda lime glasses.
So for bioactive glass, you harvest the eggs and you can break them down into eggshells, and then you do a controlled burn instead of just that regular agricultural field burn and making it into ashes. And then you do the sol gel process, making that into bioactive glass. And then you could do the same thing with decorative glass, but we can use corn. You harvest the corn, you get corn husks from that harvest. You do another controlled burn for the ashes, and then you do the sol gel process into the decorative glass.
And then following that same process by using rice plants, where we create the soda lime glass, which we believe will be the most prominent process used because of how often that this soda lime glass would be used.
Just to recap exactly what we just saw in this video, we have 3 different models that we decided to apply this glass to, which is our geodesic domes, which could be produced into greenhouses, which then creates this whole cycle of growing these rice, these corn husks, and then just recycling them for the glass. Ornamentation for the decorative stained glass window that we had. Based on what we have seen lately in our first month here in Europe, European buildings are very decorative and they really value ornamentation. And we wanted to bring that back to the US since it's losing that ornamentation.
And then we kind of have like a cycle like James brought up earlier of the rice and corn husks that are put into husks and then slide down into ashes. And then you can make those ashes into glass and then make that glass into those geodesic domes. And inside those domes, you can make greenhouses that bring you back up to the plants. And those plants are used for agro waste, like the food waste, and then brought into, so it's all like a cycle.
Thank you.